Hi everybody and welcome to our first flipped lesson about transformations. We're going to get some quick vocabulary down so we can do practice problems in class. Things you need to know. A transformation of a geometric figure is when you're changing the position, shape, or size of the figure. There's four main types of transformations. First one is a translation, so like I'm taking this triangle and I'm just sliding it over here to a new location. Second one is a reflection. That's when I'm taking a triangle or an object and I'm flipping it across a line of symmetry. Third one is a dilation, which is just making something bigger or shrinking it, making it smaller. And then the last one is a rotation, which is where I'm taking an object and turning it. So we've got two different objects. You've got the pre-image, which is the original shape, and then the image is the figure after you've done the transformation to it. Prime notation, or like these little apostrophes, are used to distinguish the image from the pre-image. And an isometry is a special type of transformation where the pre-image and the image are congruent, or the same size. So down here we've got a few examples to look at. We see two objects. We see our pre-image, or like the object we have at the beginning, and then we're doing something to it and getting the image. Here it looks like we're taking the pre-image and shrinking it to get the image. So since those aren't the same size, it's not an isometry. Isometries, the two objects have to be congruent to each other. So when we look at number 2, we see our starting figure, the pre-image. We're doing something to it, getting our image. Looks like we're flipping it and sliding it over. But the objects are the same size, so we could say, yes, this is an isometry. Exclamation point. So a translation changes the position of the figure, but not its shape or size. We're looking at a little bit more depth at that first type of transformation. So my question for you is, do you think a translation is an isometry? And then explain why or why not. I'm thinking that since when I take an object and translate it or just slide it over to the side, I'm not changing how big it is, and so those two objects, the image and the pre-image, would be congruent. So I could say yes, because the image and pre-image are the same size. I do have an isometry. When we're talking about translations in the coordinate plane, you're going to be given two numbers, so vectors, that describe how your object is moving. If you're moving to the left, that would be a negative in the x direction, or if you're moving right, that's a positive x direction. If you're moving negative in the y direction or down, moving up would then be a positive in the y direction. So let's maybe look at an example and kind of make some more sense of that. When you read the transformation -2, 3, that means that you're going to take your object and you're going to move it to 2 units to the left, so the negative means go to the left, and then 2 units up. When I see, oh, that should be a 3, oh my goodness. When I see this 3 in the y position, that means I should move my figure 3 units up. And you could also write the rule like this, x minus 2, y plus 3. So for instance, when I go out and I see this vector, what it means is take your object and move it 1 unit to the right. So that number 1 means scoot your object 1 unit to the right, and 4 units downward. The y value would tell me to move down in this case. So here's an example with a picture to go with it. It might make it a little more clear. When I see this picture, I see the point A, and then I see this point A with a little mark next to it. What that tells me is this A is like my starting point, or where A is at the beginning. And then I'm doing something to it, I'm moving it or translating it, and it ended up here at A prime. So I'm going to get my marker out and I'm going to count and see what's happening to get from the point A to my new location, A prime. It looks like I'm moving 1, 2, 3, 4, 5 units to the left. 5 units left. And then I'm going up 1, 2. So 2 units up. If I wanted to describe that using a vector, then I could put -5 because I'm moving to the left, and a +2 because I'm moving up. Another way I could write it, x minus 5, and then a comma, and y plus 2. So on the next page, you've got a couple that you can practice. Maybe we'll just do this first one together, and then we'll finish up the rest in class. So first thing I'm going to do is find the original point M and record its location. So point M is at the x value of -2 and a y value of 1, 2, 3, +4. That's where it started. And I'm going to use this vector and see where it ends up. So I want to take my x value and I'm going to add 2 onto it, or I'm going to move to the right 1, 2 spaces. Okay, so that would put me at an x value of 0. Then I'm going to take my y value, I'm starting at 4, and I'm going to move it down 3 spaces. So down 1, 2, 3. So this dot that I'm making now is my new location for M. I'm going to call it M prime. And I'm going to do the same thing. Let's see, that puts me at a y value of 1. I'm going to do the same thing to all my other dots. So I'm going to take the point N, I'm going to move it to the right, 1, 2, and down, 1, 2, 3. N prime. I'm going to take my original point O, I'm going to move it to the right, 1, 2, and then down, 1, 2, 3. And then I'll just connect my dots, make a beautiful triangle. So that triangle that I'm drawing, my image, is a translation of the original figure, MNO. Again, we're going to finish this practice up in class, so you'd want to come in ready with any questions you have and with your notes already filled in. And we'll do numbers 2, 3, 4, 5, 6, and 7 when we're all back together.